आज हम integration by parts. Integration by parts is a very important section of integration for the exam. It consists of a formula, and then there are three different types of integration at the intermediate level, and for higher level there is another type of integration. This integration by parts is very useful when you are finding the area under the curve and for the solution of the differential equations also. Let we start. We are in hurry to start this uh, topic. So integration by parts. There is a formula for integration by parts. Formula of integration by parts. I'm writing the formula here. The formula of the integration is the formula. First of all, you have to understand the formula in detail. This is U into V formula. This is also called product rule of integration. These are the two functions. And here we write here the U as it is and integrate this V. You write the integration of V. Okay. The integration of V is here and write this into the brackets, then minus. So put a sign of integral and then differentiate this, the derivative of u, and again the integration. That is this same thing will come over here. Integration of v at here, and then close this into the bracket and write a final bracket and then write it. First of all, I would like to discuss this formula, how you can apply and how you can solve the question by using this formula. Keep in your mind, the first term is always u as it is. The second term is here, the integral of this. And here, u is the function that you have to take its derivative, and v is the function that you have to take its integration. And this formula can also be written as in another way, the u as it is, integration of v here. You will write the integral of v, int for integration, then the derivative of u and the integration of the function v, the integration of v here. Okay. So this is the formula. I have written it again. Now, so many times students ask some question, how they come and how they come to know which function they have to decide for integration and which function they has to decide for the differentiation. Now here, there is a very important clue. It's very simple clue. If you think some function is easier to integrate, so take that for integration. If some function is easier for differentiation, you have to take the function for derivative. This is the one of the your way. But in particularly, we always use the function u whose derivative is easier, but it is also reducing in power if there is a power of that. And sometimes we have some special kind of questions for the integration by parts. I think it's better to first of all see the questions, types of the question, then decide which function has to be taken for derivative or for integration. Say the type number 1 of the question, type 1. If the u and v are the product of an exponential function, let this is and an exponential function, and the other function is a trigonometric function, say it is b. This is the first type, but keep in your mind it required much of the calculations, so it's better to skip this type because this type is not included the syllabus of A levels. However, the syllabus of the other boards is concerned, that is, I say, this is syllabus of FSC. It is included in the syllabus of FSC. So I'm ignoring this type because it is not for A level. So if it is for FSC, I will do it in the end of the question. Okay, the type number two. Type 2, if there is a product of e raised to the power something, as in 2x, and there is a exponential function with it. Exponential function means x, there is a x with it, or x square with it, x cube, and most probably you must know when this is only x. So we use this formula for integration, and you know, so very simple if you use this as u and this as v. Because if you take its derivative, it will be finished in the next step. So it's better to take this for differentiation and this is for integration. First of all, we write this x as it is because of this formula. You take the u as it is, or then the integration of e power x. E power x integration is e power 2x divided by 2. You know that integration of e raised to the power is always e power of 2x divided by 2 minus. Now we write the derivative of x is which is 1 and its derivative, and then write the integration of e like this formula. The integration of e is this 2x divided by 2 into dx. So we write the integration which is equals to e power 2x divided by 2 minus, take this 1 by 2 outside of the integration and write this as it is. And hence, in the last step, you can write here the x e raised to the power 2x divided by 2 minus half and then integration of it. And again, you know its integration is 2x divided by 2 and plus the constant of integration, which is this. And hence it is e raised to the power 2x divided by 2 minus 1 by 4, because 1 by 2 into 1 by 2 is 1 by 4 e power 2x plus c. This is your answer in general form of this integral. I'm repeating once again all the step. If there is a product of an x and e raised to the power a function, you always use the product rule of integration or integration by parts. So keep this x as it is, and integral of e power 2x is here minus again the sign of integral here. Because of the formula, we write the derivative of x, which is 1, and integration of v, which is in e power 2x, e power x integration this. Now we get this. Now, in the next step, we will find the integration of this exponent, but remaining terms will be the same. And finally, writing the integration of this function here. So we get our final answer. This was the first type of the question of the integration. I'm taking another question of this type. We have another question. The integration or the limits are also given 0s to 1, and you have to find the integral of 2x minus 3 into e raised to the power negative x dx. So it is the question, and we want to evaluate this. And so we're using again the product rule, and we will take this as v and this as u function. U and v formula, it is known as integration by parts. So we keep the u as it is, 2x minus 3 into the integral of this, which is minus x divided by minus 1 minus the integral, and now the derivative of this expression, which is 2. The derivative 2x minus 3 will be 2, and the integration, again the integration of e raised to power x, which is minus x divided by minus 1 into dx. So we complete the first step of this integration. Now writing the other step here. Now the first term will remains the same, and write the second term then, and we can write this negative in the beginning of this, and minus, this is negative and negative become positive 2 times, you get the integral only this one, and hence we can write this negative 2x minus 3 e raised to the power negative x plus 2 e raised to the power negative x divided by negative 1. And so we get the integral minus 2x minus 3 e power negative x and minus 2 e power negative. And because the limit is also given here, and at the end of this question, you can now find the limits of this integral. Say I would say I equals to, now writing the limits, taking e power minus x as common first of all, and write the terms inside the bracket minus 2x plus 3, and this is minus 2, and along with it writing the limits 0 to 1. So first of all put 1 here, e power minus 1, and what is this? This is minus 2 and plus 1, minus 2 plus 1, because I also put x equals to 1 here, and then minus e raised to the power minus 0 into, putting 0 here plus 1, it will be 0 plus, and therefore it is negative 1 by e, and what is this? It will be 1 on. Therefore our answer is negative 1 minus 1 by e. This is the answer of this integral. I'm repeating all the steps once again for this question. The product of a linear function and e raised to power minus x, we use the uv formula. We take this term always as u, this term as always as v, and the derivative of this first term is here, and writing this term as it is, and then writing the integral of the derivative of this and the integration of this, and then write the integration in this next step, writing this, and at the end we are putting the limit. So this is all about of integration of this type of the question. Now we take the another type of the question, and you will see this type of question again in your past paper. Past papers. Now the type number 2, say the type 2 or the type 3rd, if we keeping the first type of the product of sine and the exponential function, second type an exponential function and a linear function, third है the integration of x into a trigonometric function, say sine of ax, 2x. This is the other type, so you can say it is the type number 2. Type 2 of integration, the product of a trigonometric function and a linear function, mean the polynomial function, and for this, assuming the limits are also given 0 to pi by 4. The limits are given, then use the uv formula. It's uv formula, so then take the x as it is, and the integration of sine is negative cosine of 2x divided by 2. And you can also write the limit in the beginning, 0 to pi by 4. Because it will be very helpful to write the limits in the beginning. It will simplify your question earlier as compared to the long way. This is, and derivative, then now writing the derivative of x is 1, and the integration of sine is cosine of 2x divided by 2 with the negative with it. So it is the integration of sine 2x and dx. Now simplify and further we can evaluate this. As you know, we put pi by 4 here. It is pi by 4 and cosine of it will become pi by 2 and the whole divided by 2 minus we put 0 here, it will become 0. If you are good in your trigonometry, then you will easily see this will also be 0 because cos of pi by 2 is 0. So in the next time we write this. And writing this, negative and negative become positive. This 1 by 2 can be written before the integral and writing the limits pi by 2, 0 to pi by 4, cosine of 2x dx. And now, because this will be 0, cos of pi by 2 always 0, so it is 0 plus 1 by 2, the integration of cosine is sine of 2x. Keep in your mind the integration of cosine of 2x by 2 and the integration of sine is negative cosine x. And then writing the limits again 0 to pi by. So it is writing 1 by 2, then it is 2, it is 1 by 4. And then put the limits. Sine of pi by 4 into 2, it become pi by 2 minus the sine of 0. And you know the sine of 0 and sine by pi by 2 values. Sine pi by 2 is always 1 and sine of 0 is 0. So the answer of this integral is 1 by 2. This is the solution of this integral. Again, repeating all the steps in this. If we write this product, keeping this as u and this is v, so we can write the derivative of this term, integration of this term, and keep this u as it is, minus the derivative of x is 1 integration of it. Simplify the steps and writing these limits here. And we get this step, then further the integration of this expression. Integration of this is sine, then putting the limits we get down. So this was the second type. I would like to take one more example of this type question. Let me write here. Now the other example for this, let the limit from pi by 6 to pi by 3. And the product of the function is here x into cosine of 2x dx. Now, according to the product rule, once again, we will keep the x as it is and write the integral of this, which is sine over 2x divided by 2. And again, minus integral of what derivative of this is 1 and the integration of this is sine over 2x divided by 2. But you know the integration of cosine is integration of cosine is positive. Okay. And the limits are pi by 6 to the pi by 3x. As usual, once again, we write this constant outside, then integrate the sign again. We are writing and simplifying these steps here. We write here, and the limit over here is pi by 6 pi by 3. Now put the limits for the first step, pi by 3, the upper limit, and sine of 2 pi by 3, whole by 2, minus the limit pi by 6, sine of 2 pi by 6, and it is divided by 2. So we write the first expression, this its limits here, and integration of this. First step, write this as it is, and this is sine of 2, and the limit pi by 6, pi by 3. And this 2 can be written before this expression. Now, once again, keeping in mind the answer of this pi by 6, 3 to the 6, and sine of 2 pi by 3. Sine of 2 pi by 3, what is sine of 2 pi by 3? It is square root of 3 by 2. You can use your calculator to do this. And minus pi by 6, sine of pi by 3. And the sine of pi by 3, which if you cancel with it, it is pi by 3. And what is this? Pi by 6. Okay, it is pi by 3. So sine of pi by 3, again, it is a square root of 3 by 2. Keep in your mind, sine 2 pi by 3 or the sine of pi by 3 are always same. Now minus 1 by 2 this, and integration of sine is negative cosine of 2x divided by 2, and writing the limits pi by 6 to pi by. Because of the limit, it seems a complicated question. Otherwise, it is very simple question. And you can observe this is cancellable because these are the same term. Now we left with the only this expression. This is 1 by 2, 1 by 2 is 1 by 4. And this negative and negative become positive. And now writing the limits, pi by 3 here, cosine of 2 pi by minus cosine of pi by 6. Okay. Interestingly, 1 by 4 cosine of 2 pi by 3 is 1 by 2, negative, because it is obtuse sign, minus the cosine of here pi by 6. The cosine of pi by 6 will be cosine of pi by 6 is square root of 3 by 2. So you can take this 1 by 2 as common, it becomes 1 by 8, and the answer is negative 1, negative square root of 3. So this is the answer. Okay, we did the two types of these questions, and the next lesson I will also present the third type. I think it's enough for today. Okay, thank you. Goodbye. Khuda Hafiz. In the next lesson, we will do the further applications of this. Okay, so